little bit more after we go through the mechanism. The first thing I want to say is an E1CB. Remember, with an E1CB, it's 2 steps. First step is removing the proton. Right? So we're going to lose a proton in the hydride. Well, the first step, the base pulls it off, and we're going to push the electrons onto the carbonyl oxygen. Okay? So it's not just direct, base pulls off the proton, we kick out the hydride. Okay? It's a 2-step, E1CB. So then in the second step, okay, our enolate collapses, and it's a hydride transfer to the nitrogen on FAD. And then we're going to push electrons up, and then this nitrogen is going to pick up a proton. All right? So here it is in the oxidized form. Here it is in the reduced form. So it's like we saw before with NAD+. It's still believed to go through a hydride transfer when it's reduced using our succinate dehydrogenase enzyme. Okay? So then this gives us our product. Okay? So fumarate. You notice it's in the trans conformation. It always forms it in the trans. Now, something to point out that's interesting now is what do we do with the reduced cofactor? How do we regenerate it into its oxidized form? Well, it turns out it's going to start transferring electrons one at a time to iron-sulfur clusters that are already present in that complex too. So FAD is very different than NAD+. NAD+ can only do 2 electron transfers. FAD can do both. So here you can see it's accepting a hydride to become reduced. But when it reoxidizes, these iron-sulfur clusters can only accept 1 electron at a time. So when it offloads its electrons, it transfers them 1 at a time. That's also why FAD is necessary. Okay? And you'll see that with NADH, when it's used in the electron transport chain, again, it's going to be transferred to some cofactor that can again then do single electron transfers to allow for them to be used in the electron transport chain. So remember, it's an E1CB mechanism. We're just going to remove the proton using the base. All right? And then we're going to kick out a hydride onto the nitrogen here. So you see that we're now, this is kind of the oxidized state, and this is the reduced state. So each nitrogen is essentially gaining a hydrogen, and we can see that these 2 pi bonds have moved. Okay? Now we have a pi bond right here in the middle. Okay? But again, it's a hydride transfer. At least it's believed to be a hydride transfer. There's a little bit of debate if this actually goes through a single electron transfer. If we draw it that way, then it really gets messy. So we're just going to stick with it as is. Okay? And remember, this isn't the only time you're going to see this, right? So in chapter 17, when we're doing fatty acid catabolism, it uses an enzyme that's not the same, but it uses the same mechanism. All right? And the substrate is just a little